Good day, ma'am. My name is BLESSY ATIS Ilajas from BSEE 1A, and today, this is my output and explanation on how I understand the problem sets given and kung giunsa pag-derive ang mga answers based lang sa akong nasabtan. So, lecture 6, mirrors and lenses. So, example 2.1, solar electric generating system. One of the solar technologies used for today for generating electricity involves a device or called a parabolic trough or concentrating collector that concentrates sunlight into a blackened pipe that contains a fluid. This heated fluid is pumped to a heat exchanger where the thermal energy is transferred to another system that is used to generate steam and eventually generates electricity through a conventional steam cycle, shown in figure 2.11, shows such as working system in Southern California. The real mirror is parabolic cylinder with its focus located at the pipe. However, we can approximate the mirror as exactly 1/4 of a circular cylinder. So, letter A, if we want the rays from the sun to focus at 40 cm from the mirror, what is the radius of the mirror? B, what is the amount of sunlight concentrated onto the pipe per meter of pipe length, assuming the insolation or incident solar radiation is 900 watts per meter squared? And letter C, if the fluid carrying pipe has a 2 cm diameter, what is the temperature increase of the fluid per meter of pipe over a period of 1 minute? Assume that all solar radiation incident on the reflector is absorbed by the pipe and that fluid is mineral oil. So, solution, no? So, first is identify physical principles involved. So, ato i-identify ang physical principles nga na involved. So, sa part A, it is related of that optics of spherical mirrors. Then sa part B, involves a little math, primarily geometry, and sa part C requires an understanding of heat density. So, sa A, since the radius of the mirror manggipangita, so the sun is the object, so the object distance is essentially infinity, or the object distance equals to infinity. The desired image distance is equals to 40 cm. We use the mirror equation to find the focal length of the mirror. So as we can see this equation, no, so we add the image distance o ang object distance, so then in which it is equals to then equals to 1 over frequency. So para makuha na to ang radius of the mirror, so ato ipagawas ang frequency. So kani siya, wait lang, pink. So kani siya ikuan na siya, so muna siya makuan, so muna then dara ay, so muna siya ang kuan F, nabali ako arrow. So then ang kana mo pagawa sa FF, then F is frequency equals to 1 over object density plus 1 over image distance raised to the -1 power, no, kay nakuha naman siya, so man-negative na ang power niya. And then you must so since di ba ang naman dire is ang kaning object distance is which is equals to infinity, so mo ni siya ng infinity. Sorry, di ko magbalag drawing. So kana siya dayon ang kuan dayon ang image distance is 40 cm, which is kani siya. So mo na siya i-add dayon, then raised to the -1 power, in which the frequency is equals to 40 cm. So mo na siya ang letter A. So the radius of the mirror is equals to 2 frequency, in which equals to 80 centimeter. So let's proceed to letter B. So ang letter B is kanang kanang ang 900 watts per meter squared. So ano siya? Excuse me. So the insulation is 900 watts per meter squared. So you must find the cross-sectional area A of the concave mirror, since the power delivered is 900 watts per meter squared times A. The mirror in this case is estimated as quarter section of a cylinder. So the area of the length of the mirror is A is equals to 1/4 rather, times 2 pi r times L. The area of the length of 1 meter is then A is equals to pi over 2 r times 1 meter, in which equals to 3.14, which is the constant value of pi over 2. Dayon meron na siya ang atong r. So since di ba man kani wait lang, so kani ang r kana siya ang r, so nahimo ni siya kuan, i-convert na to siya into meter. So mo na siyang nahimo og 0.800 meter. So wala siya dayon times dayon sa 1 meter kani diri hangtod diri, so in which equals to 1.26 meters squared. So next, the insulation of the 1 meter length of pipe is then 9 times 10 squared watts over meter squared times 1.26 meter squared. So we must simplify, so we get 1130 watts. So that's the insulation of 900 watts per meter squared. So let's proceed to letter C. So ang letter C is kanang kanang ang per meter niya sa pipe over period of time. So pila ang ni-increase ang temperature sa fluid per meter. So ano siya? The increase in temperature is given by Q is equals to MC, change of temperature. So the mass of M of the mineral oil in the 1 meter section pipe is M is equals to PV equals to P pi times D over 2 squared times 1 meter. So we must substitute the given values. So since so 8 times 10 squared kilogram per meter cube times ang atong constant value sa pi is 3.14, dayon dayon times 0.0100 meter squared times ang kuan niya 1 meter. So in which we can get this, in which it equals to 0.251 kilograms. So the mass is, so the increase ay kanang the mass is equals to 0.251 kilogram. So therefore the increase in temperature in 1 minute is delta T equals to Q over MC. So equals to, ang Q na to is kuan, so di ba diri man atong watts, so kani siya kani, so kani mo nakita naman to, so ato siya i-substitute kani, then 60 seconds dayon kay 1 minute man, so there are 60 seconds in 1 minute, then over ang kuan dayon ang mass dayon niya, so kani di ba kay ato naman na get, so 0.251 kilogram times ang C niya is 1670 joules times kilogram over degrees Celsius. So simplify, no, so we must divide them all, and then the change of temperature is equals to 162 degrees Celsius. So ano siya, then an array of such pipes in the California desert can provide a thermal output of 250 MW on a sunny day, with fluids reaching temperatures as high as 400 degrees Celsius. So we are considering only 1 meter of pipe here and ignoring heat losses along the pipe. So that would be all. Thank you. So let's proceed to the problem set number 2, example 2.2, image in a convex mirror. A keratometer is a device used to measure the curvature of the cornea of the eye, particularly for fitting contact lenses. Light is reflected from the cornea, which acts like a convex mirror, and the keratometer measures the magnification of the image. The smaller the magnification, the smaller the radius of curvature of the cornea. If the light source is 12 cm from the cornea and the image magnification is 0.032, what is the radius of curvature of the cornea? So, if you find the local length of the convex mirror formed by the cornea, then you know its radius of curvature, so it's twice the focal length. So the object distance is equals to 12 cm and the magnification is 0.032. So first find the image distance or DI and then solve for the focal length. So solution, start with the equation for magnification. So when it's equals to negative image distance over the object distance. Solving for image distance and inserting the given values yields. So the image distance is equal to negative magnification object distance, in which is equals to ang negative ang atong kuan ang magnification, in which so given naman, so mo ni siya given, which is 0.32 kani siya, dayon ang atong kuan dayon ang object distance is equals to 12 cm, which is kani siya, and then we must multiply it and then we can derive this answer, in which negative 0.384 cm. So next, where we retain an extra significant figure because this is an intermediate steps in the calculation. Solve the mirror equation for the focal length and insert the known values of for the object and image distances. The result is 1 over object distance plus 1 over image distance, in which equals to 1 over focal length. So focal length is equals to same adtong kuan kanang same sa problem set number 1 kanina nga gi-kuan siya para makita ang focal length. So focal length is equals to 1 over object distance plus 1 over image distance, in which raised to the negative 1 power. So dayon dayon i-substitute na to ang kuan ang object distance, in which ang atong object distance dire is 12 cm. So mo na siya, in which ang object distance is equals to 12 cm, dayon ang image distance is equals to negative 0.384 cm, dayon raised to the negative 1 power. So then simplify dayon, we can get, so the focal length is equals to negative 0.40 cm. So the radius of curvature is twice the focal length. So di ba kay katong giingon kanina is ang radius sa curvature is ikaduhaon siya sa focal length. So ato lang siya times 2. So ano siya, r is equals to, so radius of the curvature is equals to 2 focal length. So negative 0.40 cm times 2, in which we can get this answer. So negative 0.80 cm. So na siya. So the focal length is negative, so the focus is virtual, as expected for the concave mirror and a real object. The radius of curvature found here is reasonable for cornea. The distance from cornea to retina in an adult eye is about 2 cm. So this 2 cm ang kayang kalagyo. Then in practice, corneas may not be spherical, which complicates the job of fitting contact lenses. Note that the image distance here is negative, consistent with the fact that the image is behind the mirror, and thus the image virtual because no rays actually pass through it. In the problems and exercises, you show that for a fixed object distance, a smaller radius of curvature corresponds to a smaller magnification. So that would be all. Thank you. So let's proceed to problem set number 3, example 2.3. So using the lens maker's equation. So find the radius of curvature of biconcave lens symmetrically ground from a glass with index of refractive 1.55 so that its focal length in air is 20 cm or for a biconcave lens. Both surfaces have the same radius of curvature. So as we can see here, the given is the focal length is 20 cm and the index of refractive is 1.55 and na siya. So ang ato is pangitaon na to ang radius of curvature of a biconcave lens symmetrically. So from this we must use the thin lens form of lens maker's equation. So 1 over focal length is equals to n sub 2 over n sub 1 minus 1 times the quantity of 1 r1 or the radius 1 minus 1 over r2, where r1 is less than 0 and r2 is greater than 0. Since we are making a symmetrical biconcave lens, we have the absolute value of radius 1 equals to the absolute value of radius 2. So as you can see here, this is the solution. So from this equation we can determine the radius of curvature from. So 1 over focal length is equals to, so kato siya ako giingon na is kuan. So same lang sila anhe, no? So same lang sila anhe kana kay muragiad lang siya. So munang nahimo siya negative 2 over r. So solving for r and inserting focal length is equals to negative 20 cm and 2 is equals to 1.55. So di ba kay given naman nato ang focal length and ang n2. So ato siya kuan substitute and ang atong n1 is 1. So gives r. So ato lang siya kanang i-substitute. So negative 2 focal length times the quantity of n2 over n1 minus 1, in which equals to negative 20 cm, since ang atong focal length is kuan man kanang atong focal length is negative 20 cm. So mo na siya. Then ang atong n2, in which 1.55 kani siya, then kani. Then so ato na siya i-substitute. Dayon ang kani dayong n1, in which 1 cute yun. 1 dayon minus 1 dayon. So simplify dayon, then we can so the radius of curvature is equals to 22 cm. So that would be all of the problem set number 3. So let's proceed to the problem set number 4. Yeah, example 2.4. So converging lens and different object distances. So find the location, orientation, and magnification of the image for an 3 cm high object at each of the following positions in front of a convex lens of focal length 10 cm sa A, in which the object distance is equals to 50 cm. Then sa B, object distance equals to 5 cm, and the letter C, object distance is equals to 20 cm. So as we can see, no, the given value from this problem set. So ang kuan kanang magnification of the image in which kaning 3.0 cm high. So mo na siya, din atong focal length is 10 cm. So let's proceed sa solution. So sa letter A, since ang diba kang A is pangitaon na to ang focal length sa object distance sa in which kanang 50 cm dayon. So for object distance is equals to 50 centimeter. So the focal length is positive 10 centimeter. So which gives this formula. So image distance is equals to 1 over focal length minus 1 over object distance raised to the negative 1 power. So muna siya dayon din. Ato lang dayon kanang sani. Ato lang dayon substitute ang value. So di ba ang atong focal length is 10 cm man. So muna siya 10 cm kana. Then ang ato dayong object distance is 50 cm kana siya. Kana man. So negative raised to the negative 1 power. So we must substitute this equation. We must kanang simplify this equation rather. So the image distance is equals to 12.5 centimeter. So the image is positive, so the image is real. So tinuod gid ang image niya kay positive man. So on the opposite side of the lens from object and is 12.6 centimeter from lens. To find magnification and orientation of the image, so pangitaon nato ni nga formula. So the magnification is equal to negative image distance over object distance. So then kanida yon ang atong image distance diba is kanang napangita naman nato dire kanina dire. So kana 12.5 cm. Then ang atong object distance so sa dire is 50 cm. So 12.5 cm divide 50 cm in which equals to negative 2.50. So the negative magnification means that the image is inverted since the absolute value of magnification is less than 1. So the image is smaller than the object. So the size of the image is given by the absolute value of image height is equals to the absolute value of magnification. So the object height in which equals to 0.250. Excuse me. Then ang ato ding height of the object is 3 cm kay di ba kay as what state here kanina nga is a given. So muna siya ang katas-on sa object. So next, then ana layon naman ta. So ana siya, then 0.250 times 3 cm in which is equals to 0.75 cm. So let's proceed to letter B. So for object distance is equals to 5 cm and the focal length is positive 10 cm rather. So same lang siya po, we must use this formula, no? So we must use this formula to find the image distance. So is ang nakalay lang is yan ang value nila. So muna siya, same lang siya po ang process sa letter A. Then nakalahi lang nila is ang value. So ang focal length diri is 10 cm, then ang object distance is 5 cm. So ikuan lang dayon simplify. So the image distance is equals to negative 10 cm na siya. So the image distance is negative, so the image is virtual. Is on the same side of the lens as the object and is 10 cm from the lens. Magnification and orientation of the image are found from magnification is equals to negative image distance over object object distance equals to negative 10 cm over 5 cm in which is equals to positive 2. So as we can see, no, ang sa letter A is kuan siya kanang positive ang kuan niya ang image, then negative ang magnification, then dire din sa letter B is kanang ang image distance niya is negative, then ang magnification niya is positive. So opposite sila sa letter A. So muna siya. Then let's proceed to letter C. So for object D is equals to 20 centimeter. So we must find the object distance of 20 centimeter, then ang focal length is positive centimeter. So same lang siya po ang process niya, no. So ang nakalainan lang is kanang laylahi ang value niya. So sa diri sa letter C is ang focal length niya is kanang 10 cm, then ang object distance niya is 20 cm. So simplify Japon, so the image distance is equals to 20 cm. So the image distance is positive, so the image is real. So same sila sa kanang sa letter A ganina nung positive man. So ang image is kuan po siya kanang real or tinuod. So is on the opposite side of the lens of the object and is to 20 cm from the lens. So the magnification is equals to negative image distance over object distance, in which equals to 20 cm, then 20 cm over 20 cm, then in which the magnification is equals to negative 1. So the negative magnification means that the image is inverted, so nabali siya. Since the absolute value of magnification is equals to 1, the image is the same size as the object. So ano siya? That would be all of the problem set number 4. So hello once again. Let's proceed to the last problem set number 5. Example 2.5. So choosing the focal length and type of lens. To project an image of a light bulb excuse me, on a screen 1.50 meter away, you need to choose what type of lens to use, converging or diverging, and its focal length on figure 2.8. So kani siya mo siya ang light bulb sa focal length. So the distance between the lens and the light bulb is fixed at 0.75 meter. Also, what is the magnification orientation of the image? So as we can see here, no, nga ang given niya is kanang ang kalayon sa light bulb sa screen, so 1.50 meter away dayon. And then ang kuan dayon ang distance between the lens and the light bulb is fixed at 0.75 meter. So ang atong pangitaon is the magnification orientation of the image. So the image must be real, so you choose to use a converging lens. The focal length can be found by using the thin lens equation and solving for the focal length. So the object distance is equals to 0.75. So diba, so given naman meter, and the image distance is 1.5 meter. So same lang siya sa 1.50 meter. So solution: solve the thin lens for the focal length and insert the desired object and image distances. So diba from the past nga problem set, from problem set 1, 2, 3, and 4, so muna siya ang gigamit nga formula. So same lang siya po sa problem set number 5 muna atong gamiton. So muna siya, then so which is the formula is equals in which 1 over object distance plus 1 over image distance, in which equals to excuse me, 1 over focal length. So same lang siya po, no, nga since focal length man atong gipangita, so ato siya ipagawas. So mana siya, din same lang siya po ng kuan, din ang atong object distance is 0.75. kana siya kay mo man siya ang given, no, kana siya. Dayon ang image distance din niya is, so kani siya 1.5 meter. Dayon raised to the negative 1 power. So then simplify lang dayon 1 over 0.75 meter plus 1 over 1.5 meter raised to the negative 1 power is equals to 0.50 meter. So as you can see here, the magnification is equals to negative image distance over object distance. So diba ang the value of image distance is 1.5 meter. So ato lang siya substitute dayon ang image ay object distance rather is equals to 0.75 meter. So 1.5 meter, negative 1.5 meter over I divide 0.75 meter, in which is equals to negative 2.0. So that's the magnification. So the minus signs of the magnification, is means that the image is inverted. So nakuan siya na invert mo na ang meaning sa kuan negative sign. So na invert ang iyang image. The focal length is positive as expected for the converging lens. Ray tracing can be used to check the calculation. So as we can see here in figure 2.28, so kani siya ang ray tracing niya is na kuan sa kuan. Then as expected, the image is inverted, is real and a larger than object, no? So as we can observe this figure, no, kanang murag kuan siya kanang murag na invert bitaw, di ba, kay naman diri ang kanina blue. So di ba diri man ang bulb, no? So kung makita ta sa bulb is na dire dayon, kung makuha na dayon diri sa screen is naka-inverted na siya or naka-bali na siya. So mo na siya ang kuan light bulb placed on kanang 0.75 cm from a lens having a 0.50 meter focal length produces a real image on a screen. As discussed in the example, ray tracing predicts the image location and size. So as we can see, na invert ang light bulb nga image. So that would be all. Thank you, and to God be all the glory.